more questions?
I'm gonna pull this up and I'll show you what it's doing.
So that's key. In my classes, the better you can do this, the better all this is. Because that's what I do in here tonight. I wanna harp on this a little bit more and actually pull in the circuit and get you used to the AC part of it. I've got Scilab open to do the hard math. I got spreadsheet to do the hard math. So that's what I sort of wanted to do tonight. At some point, on the worksheet, I asked you to own the contacts of the transformer. So here's the transformer. You can own it any way you can. Here's another transformer. That's actually got two sides. That one's a little more complicated. Also want you to own the coil of the contactor or resistor or relay. So here's the coil. Here it is. And if you think that relay is too intimidating, you can have this one, but you got to figure out which one's the coil on it. This is Daryl.
Tell me on the side.
Yeah, LibreOffice is working on Windows 11. And right now it's version 7, so 6.4 will work. You can also own the relay contacts on the big relays. Normally open, normally close, and then push them. You can shoot that. Do them in all different states. Just so you got some experience doing it. So that was my little myself there.
Here's what it's saying. I'm gonna kill this thing and I'll stop saying it. Kind of moving by something.
No, you don't need it.
So even when I go out of it, I cannot get anything.
Oh.
Then if I hit and
Go to the internet.
It tells you what it is. It's freaking tiny. I need my microscope to see it.
Alright, do a LibreOffice. LibreOffice. I'd go to the main website and go to download from that because you just never know. And then download and then install if you're the operator. And when it comes up letting you install it. Probably going to your download. How's your Windows 11? Okay, it's in process. All you should have to do is just
Can you send me the spreadsheet to that?
you can open the spreadsheet with that. Now what you'll have to do is open LibreOffice.
Okay.
Save the spreadsheet from the class to somewhere on your computer. And then with LibreOffice open, go to that spreadsheet and tell it to open.
Okay.
Because right now on your computer, it's going to try and open it with Microsoft.
So if I go where I downloaded it, I can right click, save it, and then go.
Well, it's going to be a program on your computer like any other program. Just open that file from that program.
On the worksheet, specify.
Actually, my worksheet says do between all of them. So you got X1, X2, you got all those X's. You can write down the values, yes.
I didn't know.
It's coming up because I've been through most of the worksheets in class. So. And I don't think I put a grade on there, but I can see if I've got a grade on the grade.
By the way, so it was next year.
So you got a grade on 17?
No, it's not that great.
I got 2.
Okay.
But I do.
I do too. My 17 says 1 out of 100.
Yeah, I got a grade on mine too.
Mine says 1 out of 100.
Oh, okay. I ain't that.
Yeah.
Good. I ain't got internet now, so we can do it. Turn that back on. I'll make sure I do that by the time.
Is that my phone, the little one in the middle?
Let me go into this new song. Make sure. About 100 on that.
Whoa, two, five,
All right.
relay that looks like soul. Alrighty. So, with the triangle thing in mind, looking at this first promise series, but I've got 100 ohms of resistance and 100 ohms of inductive reactance. Okay? Had this number been in Henry, what would you have to do? This number been in Henry, you'd have to do that 2 pi FL. But it's not, it's in ohms. So we're good. So what is my impedance of this circuit? What is my impedance of that circuit? If I could add two 100 ohm resistors, what would you tell me?
200 ohms.
You tell me it's 200 ohms. How'd you get that?
They're in series.
You added them, right? Because they're in series. Are they in series?
Yep.
Alright, so we want to add them. So my impedance is, what's my real part?
200.
Oh. For this circuit. What's my real part? Through this for a reminder. Which is my real part? 100 ohms. See that? What's my imaginary part?
It's going to be your.
The other 100. Now, is it positive or negative imaginary? Positive imaginary because it's an inductive reactance. Plus 100I. Guess what you just did? You came up with that impedance. How hard was that? Don't override it. Now, what if I wanted it in color form?
Plug it in. It's for multipliers.
So I'm going to go out 100, up 100. I need to know the hypotenuse, and I need to know this angle.
So you do it the same thing.
You do the diagram there, and you can figure out what you want to do. So I'm going to do 100, and 100, and I get 141, 45. Now I should back to 45 twice. So my isosceles triangle, right? Isosceles right triangle. So I know I should make angle 45. And if I thought about it, I'd have made it 140. Angle 45. So those are equal, right? Ohms. One is rectangular, the other is polar, isn't it? You okay with those? Alrighty. What's my current in the circuit? So if somebody gives you voltage and they give you the impedance, can you come up with a current? What do?
AC versus voltage.
I equals V divided by C, right? Do I know V?
Yes.
I know C. I'm dividing, so what's the easier form to use? Oh. Add, subtract, rectangular is easy to use when you're dividing, multiplying. Oh. So I've got 50. What's the rectangular form of this 50? Now I'm asking what frequency. What's the frequency? 60 because I didn't say. Do you see an angle here?
No.
Then you assume the angle is 0. So what I'm going to do is I'm going to take 50, angle 0, and I'm going to divide by 141, angle 45. What am I gonna get? Well, we did this for a reason. What's 50 divided by 141? So the nice thing is, if you got a free cell in your spreadsheet, you can always plan. 50 divided by 141. Survey said I got 0.35, 461, so we're going to call it 0.35. What's my angle? Zero minus 45 is minus 45. There's my current. What's the unit for current? Amps. Okay? So, if you were to build this circuit, and you get out your ammeter, and you put your ammeter in here, your ammeter is going to read. It's going to read 0.35. Your ammeter won't tell you what the phase angle is, but it will read the magnitude of the polar part. So your ammeter in your toolbox reads the magnitude of the polar part. It does not tell you anything about the ammeter. Okay? So, what is that in rectangular? .35 angle minus 45, right? And I get we'll call it 0.25 minus 0.25.
Whenever you're doing your angles, when you find your amps, you just subtract them.
What, here?
Yeah.
You subtract if it's
Division.
if it's multiplication, you can add. Now, if you start trying to add and subtract these numbers, then you kind of almost convert the rectangle. Because there is no easy way to do it.
But the other ones
You
just.
almost got to let software do it. So there's my amps. So earlier I had the 100, 141 angle 45. So let's write that in here.
Convert it back.
I just plugged it in. And then plugged in the polar to convert to the rectangular yellow. So I had 100, 100, 45. This is 141. Right?
Yep.
Okay, this is something called my impedance triangle. Every circuit will ultimately have one impedance triangle. So I've got an impedance triangle for that circuit. That's it, because I know all the parts. So if I've got something parallel and I've got to do some solving or whatever, I'll still come up with an impedance triangle for the total circuit. Well, not this one, because this one's harder to do. Unless you do some superposition, then you could. Impedance triangle. Now, what do you notice about this angle? As it compares to this angle.
One's positive.
Okay? If your voltage is angle 0, which it is, Your impedance triangle angle will always be the same magnitude but a different sign than your current. Okay? Always. If your angle is zero voltage, you'll always notice that. So it sort of gives you a little way to check. Right? So, now how did we do power in DC? How did I tell you to calculate power? I told you that I squared R, right? B squared over R, and what's it? B times I. This is power. 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 And I told you when we get to AC that B times I was no longer be power. Alright, so do we know what I is? And do we know what V is? 50. We know the angles. Okay? And I know this what? What is this in rectangle? So here's the polar. What is that in rectangle? Is it 50 plus 0i? You okay with that? Alright, now the magic happens.
Is that a V squared in the second power?
Yeah.
Okay.
V squared over R. One of your power points. Right? Okay? In AC, if we've got these complex numbers, we can do everything we want to with this. Alright? V times I. What's my V?
50.
50 angle 0. What's my I?
35. Oh.
0.35 angle 45.
Minus 45.
I multiply those out, what do I get? 50 times 0.35, now fancy angles. I know my angle could be minus 25, right?
Yeah.
What is 50 times 0.35?
17.
17.5, angle 45. Remember that for a minute. Now I've got another form I can use, right? 50 plus I and 25 minus 25i. 50, since this is 0i, what am I going to do with it? I ain't even going to bother it. So this is 0.25 minus 0.25i. What happens if I multiply those together? What do we get?
12.5.
12.5 minus 12.5i. So let's remember that. What do you think I will get if I convert this one to rectangle?
17.5.
I'll get this. What happens if I convert this to polar? I'll get this. Isn't that neat? So if I do one of them and then do the conversion, I get the other. But let's graph it. Let's graph it close to the impedance triangle here. I can't. Okay. I'm going to do 12.5 out, 12.5 down. So I'm going to have a hypotenuse of 17.5. We have an angle of minus 45 degrees. Now, how does this triangle, which is my power triangle, compared to my incandescent triangle. This one.
Reverse, baby.
The angles are negative, but they are what we call similar triangles. So what does it mean when triangles are similar? They have the same angles. Okay? So this is a 45, 45, 90. This is a 45, 45, 90. And so I've got my symmetry. But the even better news is, how many watts does my circuit dissipate? I want to know power, I want to know VA, I want to know bars. But guess what I need? I need my power triangle. This, the hypotenuse, is my VA. So what's my VA? This circle. 17.5. VA. What is my watts or my power for this circle? You go to your impedance triangle, and you look for the horizontal part, and what do you see?
12.5.
12.5. This is my power or my watts. So that's power or watts. 12.5. And now bars is my something called volt amps reactive. And so if this is power and this is VA, that leaves this side to be something called volt amps reactive. Which people don't normally ask for, but I am in this case, what's my VA reactive? 12.5. Bars. Now, could I have come up with power the other way? Using the I squared R formula. Or V squared over R. Could I have done that? Okay? Power is I squared R. I said in AC, we can't really square. We've got to use that complex conjugate. Remember how to get the complex conjugate. So my I is 0.35 angle minus 45. 0.35 angle minus 45. I need to multiply that times its complex conjugate, which is what? Y'all remember? What's the complex conjugate of that? I changed the side of the angle, right? Man, y'all just studied this last night. When I multiply these, when I multiply these, what's going to happen to my angle? What's going to happen to my angle?
Yeah.
I'm going to add the 0, right? Which puts me on the horizontal. Then I'm going to multiply all this by what? The 50. No, the impedance, which is what? No, my resistor. This is resistor, not impedance. It's going to be 100. That's 100. So 0.35 times 0.35 times 100 is what? .35 times 0.35 times 100 is?
I'm sure it is 12.25, yeah.
35 times 0.35. What's that? 12.25. 12.25
for the price? Close.
Rounded,
Oh,
rounded. 12.25, but it should, if I hadn't rounded, it should come out exactly what we got to this side of that right triangle. That's my power. Okay? So I'll talk about power triangles, and I'll talk about impedance triangles, and then solving circuits. I think actually, if you go through the trouble to do the complex numbers, everything's a little easier. A lot less formulas to worry about. The only formulas you got to worry about is how do I convert? How do I convert? Now, what about the next problem? Y'all got that figured out for me, right?
It's gonna work.
And I've got problems like it on the worksheet. That's why I'm doing it for y'all. I'm gonna erase this, okay? No, not that. Yeah. All right, now I got two things in parallel. What about that?
R1, R2.
Okay. This is R, so what is the rectangular form of a resistor? This is 200 plus 0I, right? We don't usually write the 0I. But when we see a resistor, we can add a 0I there, and if you grab it, we can call it 200 angle what? 0, right? Okay, what about this one? I didn't give it to you as capacitance, I gave it to you as ohms, so I don't have to do the 1 over 2 pi L. Trying to save a little time. But it's capacitance, so what does that mean? It's 0 minus 200I, right? Or how else can I write it? 200 angle what? Negative 90. So if I start here and I do my angle, it's negative 90. For capacitor, that's always the case. So it's not like it's going to change on you. Okay? So these are my two impedances in imaginary. How do I get a common impedance? And I could do this one easier, but that's okay. How do I get a common impedance? What did we do when we put resistors in parallel? One over RP equals 1 over R1 plus 1 over 2 plus dot dot dot. 1 over impedances in parallel is going to equal what? Look familiar? You can't figure that out.
oh yeah.
Cool. Cool. So 1 over 200 plus 1 over minus 200I was the common denominator. Now we're ready to go off to grad schools, and first I'm going to find. So I'm going to do 1 divided by, with parentheses, 1 divided by 200 plus 1 divided by minus 200 times percent I. Can you see that?
Yep.
And I got to close parentheses.
Plus 100. I do that to recognize that percentage.
Okay? So the 1 over minus 200I, put in parentheses, so we got minus 200 times percent I, that tells Scilab I'm using the imaginary operator. And I did the 1 over, so I'm going to come out with the CP.
Oh, you did the 1 over in the exact same problem instead of doing it and then 1,
I
okay.
should have added in this fractions and then did the 1 over, but I went ahead and did the 1 over up on top. So I got 1 divided by, and then I added the fraction. I'll come out the same answer. So my CP comes out to be what? 100 minus 100I, right? The unit for impedance.
Ohms.
Ohms. So don't feel funny there. What is the rectangular?
Does that say percentage I again in the?
Yes, percent I. And I think if you do percent and type EI, it does pi exponent. If you do percent E, it's got the E constant somewhere programmed. I believe, I don't use those a whole lot. All right, what's my rectangle form? What's my rectangular form of 100 minus 100I?
141.
Well, this is going to be similar except for the minus sign here, right?
141.
So it's going to be 141 and angle up.
Negative.
Negative 45. Negative 45. Angle minus 45 ohms.
Where are we getting the 141?
If I go out 100, down 100, what's the hypotenuse? This is 141, and my angle will be minus 45. There's my impedance triangle. So what do you already know about the power triangle?
Wait, 0? Or wait, it'll be
similar. So
similar.
It's 45, 45, but it's going to make a positive 45. You already know that. You already know what the power triangle is going to look like because this is the impedance for this circuit. So what's my current? What's my current? Man, I'm what's my current? Divided by Z, right? Ohm's law. Seen Ohm's law in this class? Have you seen Ohm's law in this class, Darryl?
Yeah. Yeah. Yes, sir. Yes, sir.
That's my favorite.
So 50 angle 0 divided by this angle minus 45 is going to be what? So we should get 0.35 of an angle of what?
45.
Positive 45. Yay. What's my power in this case?
Like the same.
V12.5.
0.25. If you do the calculations, will come up with what we get. 0.25I. Now, if I multiply V times I, what do I get? I get my VA, my power, and my power triangle, right? I'm good. So my V is 50 angle 0. And we'll multiply it times my I, which is 0.35. Angle 45. And what do I get? I'll bet you I get 17.5 and an angle of 45.
Angle of 45.
What do you think the two sides would work out to be if I convert
5, 12.5.
12.5 and 12.5? So what is my power for that circuit? Where on the power triangle are the power?
Still gonna be 12.
Yeah, it's still gonna be 12.5. I should have changed numbers. Power I'm gonna look at is positive on, always. It's gotta be in the same direction as my R. Which direction is my R? Positive horizontal. So my power in this case is 12.5 watts. What's my VA? The hypotenuse.
25.
17.5. What's the unit for VA? You know what it is. It's VA.
Oh,
How do you get VA? Multiply both times amps. What's the unit? VA.
VA is VA.
So that's a nice one. And then what's my bars for this one?
12.452.
12.5 also.
That's volts, amps, reactance.
All hands reactive. So I did a series circuit, I did a parallel circuit, and then I'll do a more complicated
What worksheet is this on? Okay.
But I do ask for power triangle, impedance triangles, stuff like that, so I wanted to have the problem that you see, that you come to class for, right?
Right.
Right. Okay. You good with those two? Now, when you get home, how much of this you gonna remember?
All of it.
Just send me a video.
I'll send it to whoever needs it.
So what?
Mm.
This.